Welcome to another episode of Studio 6 Paranormal Podcast. I'm your host, Jay Hill, and my co host, Shane Feek. We
Hello.
are, uh, we are broadcasting live in Lake Geneva, Wisconsin at the Maxwell Mansion Hotel, the very spirited and very wonderful, beautiful hotel. So, without further ado, today is going to be Tech Talk with Shane. So, right now, I'll just let Shane take the reins.
All right. So, on previous shows, we've always talked about this device or board that we use to record stuff with. And so today, you guys are going to get to get a tour of the device. If we have enough time, we're even going to have some audience participation with the device. So, I guess the first thing I'll start with is I'll just get a picture up of it, and so that we can um, just kind of go over what it is. So I'm going to go ahead and share my screen here, and you guys should see this soon. All right,
And there it
so
is,
there it is, the device.
the
It really
device.
doesn't, yeah, it doesn't really have a name yet. I mean,
I
it's
like the
all,
device. I think the device is kind of cool.
yeah,
It's
the device,
different.
yeah. So, so basically, this is a photo of it. Soon we'll have some live video and we'll show it actually in operation. But um, I think the most important thing here right now is just to kind of go over what the different pieces do, why they're there, and what they're useful for in the ghost field. So hopefully everybody can see my mouse cursor here. I'm going to use it as my pointer. Um, Down here in the bottom right hand corner is a big box with a bunch of holes. That's basically the power supply. It supplies a clean amount of voltage to all of the rest of the devices on the board. Um, the nice thing about this power supply is it can plug into any standard outlet. I also have a portable battery box that it can be plugged in. So if I'm in a location that doesn't have commercial power, we can still run the board. Um, the next thing up here in the top right corner with the big red button and this part, most people probably recognize that as a Raspberry Pi. A lot of DIY people, do it yourselfers, electronic hobbyists use Raspberry Pis to do all kinds of things. It's basically a little tiny Linux computer, and it's basically the brain for the board. It's the big brain. There's actually two brains on here. We'll get to that in a bit, but it's the big brain. It's the main control unit. It's what's recording the data. It's controlling all of the other instruments, etc. So that's the brain power. Now into that is also right here on the edge is where you'll plug in a USB stick when you're actually going to record data. And so that's how you get data from the board. The board directly creates Microsoft Excel files. So you can just literally open up your data in Excel, which you're going to see here in a little bit. I will do some of that. The next little device over is a little white box. That's the buzzer. The buzzer has multiple functions. Number one, um, it buzzes when it starts recording. This is important because if you have voice recorders doing EVP or you have video cameras videoing the board, you will hear in the audio like a buzz sound. Matter of fact, tonight when we start it, you'll actually probably hear the buzz sound when I start the recording. So, what that does is it lets you synchronize because remember, this thing is taking readings every second. So, you want to be synced with your video, your audio, and the data right to the second. Because if you have an anomaly, let's say you hear in your video or see on your or hear on your EVP, you want to be able to go back to the data and find that to the second to see, okay, did something happen on the board at the same time as the video or audio anomaly? Okay. So synchronization is very important. Again, it's this little white box up here in the top part. The next part we'll go down to is the little LCD display right here. This basically is kind of a status of what's going on. When it first boots up, it boots up like a computer, and it actually says ready across the screen. And then in that case, you would push, when you're ready to record, you push and hold this red button for like 3 seconds, and it'll start recording. If you press and hold it again for 3 seconds, it will stop the recording, okay? So this basically, as you can see on here, maybe it says recording, and it's got like 35 records. It counts every second as it's recording. That way you know it's still recording, you know it's working, everything's functional. If there's an error or something has some kind of an issue, which typically never happens, but has during early development, it'll actually show the error on the screen, and you can, start the recording again or fix whatever the problem is. The next little part down here, this black box that says Kexin, this is a solid state hard drive. This is where the software that runs all of this stuff is stored. You can also store ghost data there. If you do that, you have to do a lot more steps to get it out. So normally I have it write the ghost data to the thumb drive that's plugged in over here. So anyways, this black box that says Kexin is actually the hard drive. It's like a 256 gig. It has all of the software to run all of this equipment. So now that we've talked about the power, the brains, the display, the storage, and the buzzer, we're going to start getting into the actual sensors and what they do. So in this, we're going to start down here in the bottom left. Bottom left corner, this green thing with a circle is a metal detector. If you take a coin or anything like that and put it near that, this little red light will light up, and it will say, yes, I detected metal. It's kind of a yes, no, a 1 or a 0 kind of an output. So in the data, you'll see rows of zeros, and then you put a piece of metal near that thing, and then you'll start seeing ones. So you know, okay, the metal detector seen metal. And again, the little LED lights up, and that's the metal detector. The next thing we sense over here, this yellow thing right in the middle, this yellow board with this metal tube, this is a Geiger counter. This measures beta and gamma radiation. Same thing like you would think. Like if you put a piece of uranium near this.
Holy cow.
Yeah, huh?
I said, holy cow.
Yeah, it'll pick up a piece of uranium, an old smoke detector that has radioactive americium in it. It will do that. And again, this little light will blink every time it sees a particle of radiation touch it. It then, through this wire, reports it to the brain, and the brain records it. Same thing with this little wire this wire reports for the metal detector. So we're watching, so far, metal, we're watching radiation in real time. This next little blue board right up here, that one is the light sensor board, and it can measure infrared in 0 to 1,000 scale, ultraviolet in 0 to 1,000, and also visible light in 0 to 1,000. It's the level of the light. Most of the time, I don't care so much about that because ghosts probably don't change the light level in the room, although maybe they could. But it's partly to remind me, did we do this investigation in the dark? Did we do this investigation outdoors? Because I can tell, okay, if it's got a lot of UV light, we probably did the investigation outdoors. If it's dark and all the sensors are dark, we probably did an investigation in a darkened room. If it's dark, but we keep getting flashes of infrared that are very strong, that's because people are walking through the room with their fancy infrared cameras, and their infrared illuminators are shining on the board, and it sees it. So that's kind of just an interesting thing. But anyways, that's what this little greenish blue board here, it does those 3 light sources. Next up is, remember I said there were 2 brains. This other little blue board that's right above here with a big fat cord plugging over into the main brain, That's the second brain. It's running this whole group of sensors right here, because they needed a different kind of interface than the main one. So it has two brains. This is the second brain. This is the first main brain. So this brain is running all these sensors around here. All right, so that's the brain part. This big globe with all the little spots is a 360-degree infrared motion sensor. So if anybody comes in the room, an entity comes in the room, a cat comes in the room, it will see, because it can see in 360 degrees, it will see the movement. And it will record a 1 for movement and a 0 for no movement. Okay? So then right above it, these two little can-looking things, they look like eyes. They are ultrasonic distance measuring devices. So what happens is, if the motion sensor sees motion, this thing will tell me how far away from the board the motion occurred. So, and it tells it in centimeters. It's everything is done in metric per scientific standard. So it'll say, okay, I saw motion 40 centimeters away from the unit. Now, I don't have a way to tell which direction the motion came from. That's a thing called LiDAR, and it's very expensive, and I don't have that yet. Maybe this blank space in the board may someday get a LiDAR unit so I can tell distance, motion, and where it came from. Probably not super important in this idea, but
now to kind of get off the, not to get off the topic, but how much does one of those lidars cost?
A decent unit, maybe $700, $500.
Okay.
I mean,
is it big or is it a small
no,
piece?
it's physically a little spinner disc about the size of that green disc, maybe 2 inches and 2.5 inches in diameter.
Okay.
And it spins at a high rate, and
right.
it looks around in a circle, and it makes a map of the room. It's the same thing that self-driving cars use to find street signs and pedestrians and hopefully things like that.
Oh, wow.
So they are expensive. They are commercially available. It's just, you got to buy the thing. It's fairly expensive.
Where would you get one?
Scientific supply shop or like that. I mean, you can even order them from like maybe DigiKey, which are electronic supply shops. You can order them, but you got to get your credit card out and let it warm up a little bit. So I don't have one on here yet.
So it's on the list.
It's on the list. There's a physical spot on the board.
Okay.
We could have it someday. So then you'd have distance, angle, and whether you had motion or not. Most of the time, what it finds is other investigators that walking through the room, which is also why I always video the board while I'm running it, because if I see all kinds of sensors going off, I want to know, okay, did somebody just walk by the board or go over there? Ooh, that thing's cool, and start looking at things.
Okay.
All the sensors go off because their cell phone will get close to it. It'll see their motion. It'll see their heat. It'll see all the stuff. And it looks like you got this massive entity and the demon's going to take over your space. But all it is, Mary went over and looked at the board and goes, oh, yeah, that thing's cool. So you videotape it with a real wide angle camera that can see the entire room. So nobody can sneak up there and prank the thing or mess with it without being seen. So that's a thing. Next thing coming up here is a little tiny black blob that's up here at the top. It's probably hard to see for most viewers, but it is a flame detector. We normally do not want this detector to go off, because if it's going off, you should probably be vacating because you have active fire in the building. Even a candle at maybe 2 feet or so, it'll see a candle. So it can see flame quite effectively. Okay. And the way it detects flame is pretty interesting. It actually looks at the infrared, and it has to be pulsating. So you could have an infrared flashlight shine at it. It'll be like, haha, joke, not for you. But you put a candle near it that flickers, or a flame that flickers, and it'll go, oh, yeah, you got fire. So that's a neat sensor. It was cheap. It is. It was a cheap sensor, and it was easy to write the software for, so I added it.
Now, you wrote all the software for
all the software for every piece that's on here. I wrote the software for it, for both of the brains, et cetera, et cetera. Yes.
Wow.
Okay, so Let's see. Next sensor is this little black square with two brass colored dots. They're for scale, they're about the size of pennies. Okay. Matter of fact, I think I put a penny on there and spray painted around it to make the spot.
Hmm.
Those are touch sensors. Think of the old 1980s touch lamps that were so popular.
Oh yeah.
Touch on, touch off. If you touch one, it'll make a one. You touch the other, it makes a zero. So it's an on off thing. So the idea is, hey, say, hey, if we have anyone present with us, can you touch, the left circle? Can you touch the right? And we might even point at it, or I might even demo it. I'll say, okay, I'm going to touch it, and I will touch the button, touch the spots, and then of course when I go back to the audio, I will hear my voice saying that, and so I'll know to ignore that little blip.
Right. Right.
But that shows the entities. This is what you need to do. You
Now
know,
is that
it's
so?
two
Are
little
they?
pieces of copper.
Oh yeah. Okay. They're flat pieces, right?
Flat pieces of copper, and
Uh,
when you touch them, your body's energy gets picked up by this brain right here and goes, oh, somebody touched that.
okay. Let's say, can you put like some type of like a wire extension to
Sure, you could put it, you could
I mean,
extend
like to
that.
make it kind of high so that it's kind of up and open.
You
And,
could, yes. I just glued it down to the board.
right,
It looks
right.
like sticky
I,
tape.
I didn't know if that would affect it in a negative way or not.
Negative. No,
No, okay.
it could be moved. It could be remoted, I guess would be the words. So, anyways, that's a touch sensor. The next part we'll get to, we'll slide over here towards the middle. This blue square that's on the big red board, that is temperature to a tenth of a degree, humidity to a tenth of a percent, and barometric pressure to a tenth of a bar.
Oh wow.
So that gives you all three of those. With that, it can also calculate dew point. So because a combination of barometric pressure, temperature, and humidity, you can actually run a formula and calculate the dew point like you see on the weather report.
Mm-hmm.
So that's a neat thing. That's what that little sensor board does. The next sensor board down is a 3-axis magnetometer, which measures magnetic fields. For the ghost community, this is equivalent to your, what's the name of that meter? That's the blue one with the big needle that goes back and forth. It's the natural EMF meter.
Okay.
It's a very common one. Most ghost hunters will probably know about it. That's its equivalent. It can
Okay.
see it. It is sensitive enough. The board even knows which way it's oriented: north, south, east, and west. It can see the Earth's magnetic field. So you can actually know which. When I set the board down, I can dig around in the data and I can actually find which way the board was set down in the room.
Right.
So that's what that does. It also does accelerometer, a 3-axis accelerometer, X, Y, and Z direction. So if the board physically gets moved, like there's a vibration or a shaking, or the entity decides to pick the board up and throw it,
Right.
it will show in 3 axes that the board was physically moved.
Oh wow.
And it's even sensitive enough, it can tell which way is down because it can sense gravity. And so if you flip the board upside down or standing on its side, it can tell you that, hey, I'm not in my normal orientation in
Wow.
the data.
This thing does everything.
Yeah, pretty much. That's why I said it takes an entire vehicle full of equipment and puts it all on one board and records it without bias.
Right. Right.
And so the other thing it can do is, if you're heavy and you walk through the room and the room has wooden floors, you will actually show up on the board. Every footstep will show up in the data as a blip
Oh wow.
because it can sense the floor shaking.
Holy cow.
So that's pretty cool. The other thing it has is a 3-axis gyroscope. So if the board was put in, let's say, a moving vehicle,
Mm-hmm.
you could see when the vehicle accelerated and what angle it did and how fast. And if it slowed down or turned a corner, it could tell you, the board could tell you, and with the compass, tell you which direction you're going. So literally, you could put this board in a moving vehicle drive a path on a map, and it could probably follow along just by watching you turn, accelerate, and decelerate.
Wow.
So that's kind of a neat thing.
Mm-hmm.
This tall stand-up board right here is a high precision clock, and when the board is plugged into the internet with an Ethernet cord, you can actually sync that clock to within a few microseconds to the internet, or at least
Okay.
milliseconds at the most. So what that means is that all of the recordings that are done on the board are based on that clock. So what I usually do before I go on an investigation is plug the board in, do a quick diagnostic, let it sync to the internet. And so then when I take it that evening, I know I'm within a few milliseconds of the absolute true time of the world. So
Wow.
that way, when I get anomalies, and let's say I want to correlate it with something that happened, far away, or something that happened on the internet, that happened during the time frame of some sensor blip, I now have that because I know to the millisecond what time it is.
Mm-hmm.
And those times are recorded during every second, which we'll see here in a little bit when I start playing around with some data. So the clock is important. The next board over here has two items on it. This little set of chips and components down here is an EMF meter. Think
Okay.
of a super high precision K2,
Okay.
but not hokey.
Okay.
This is lab grade. It gives you a good reading. It's very steady. It can stay stable for hours, and it gives you a standard EMF, single axis standard EMF, just like you would take your handheld EMF meter and go around
Mm-hmm.
and look up
Right.
stuff. Same
Right.
thing. Then the next little chip with its related components is connected with this wire to this tall antenna. And you probably can't really see the antenna, but it's about maybe 2 foot tall.
Okay.
And that's the ion sensor. And it can tell if there's positive ions or negative ions. And it's sensitive enough that a person can stand near it. And if you take even like an inch step towards it, it can see you coming towards it, and it can see your energy around your body.
Oh
And if you
wow.
step away, it can see your energy go away. So I can
Now,
tell
does
if
it
you're,
is there like a visual picture of this, or is it, you know what I mean? I mean, do you have it where you can?
oh, I mean like a video.
Yeah.
I have never made one, but I've put my hand up next to it, and you can actually watch the numbers increase when my hand gets closer. And then I take my
Okay.
hand away and you can see the numbers decrease. I mean,
Okay.
you can
So it's all based on numbers.
everything in here is numbers. All
Right.
and you guys are going to see those here in the next 5 minutes or so.
Okay.
We're actually going to bring up an investigation that I did at a small car dealership last week,
Okay.
and we're going to show what data looks like. There was a couple places where I actually went in there and actually, poked at the plasma ball and did some stuff so that I could have data to show for you guys. So we're going to show you how I get the data out of it, and how I actually do an post investigation summary. Okay.
Okay. Okay.
So, anyways, that's what that antenna is. It's an ion, positive and negative ion sensor.
Okay.
Matter of fact, I had to mount it on a piece of special made nylon because the board itself had enough energy. It was picking it up right through the wood. So I was getting false readings. I had to mount it on this block of white nylon.
Oh wow.
Yep. So a couple other things that are kind of neat. Over here is a switch. You can't see it from this side because it's on the back, but there's a switch. It's just literally a toggle switch. You can flick it up and down. So what I do with that switch is, if I'm going to, let's say I'm going to do an EVP session. So I've had the board sitting there. It's been running for like an hour, just picking up the environment.
Mm-hmm.
We're going to sit down and have a formal EVP session around the board. Okay.
Okay.
So I would flick that switch when we start the session. All that does is put a marker in the data that says, hey, we started a session. And so then when I go back to the data, it's like, okay, I started exactly here and I stopped exactly here. So I'll flick the switch off when we're done with our session. So that way I know that I can compare the data during that session to the data outside, which is my baseline. And I can say, okay, during that session, during these questioning, did we get scientifically, statistically significant changes in the ambient environment? And so that's what we do.
Okay.
So that switch lets me mark. Now there's also a cord that I don't, this little gray cord that's kind of going off into the infinity there, off the top of the picture.
Yeah.
That is hooked to literally it's a nurse's call button. Like you'd see at the bedside of a hospital. It's just a little button you press with your thumb. And that is plugged into the board. If you press that button, it will just put a little mark in the data. So let's say you're sitting in the room and all of a sudden you feel this chill, or you feel something touch you and you're like, ooh, that was weird. Press and hold the button for a couple seconds. It will put a marker in the data. Then when I come back later, I'll be like, oh, hey, we need to look at that spot because something touched me while I was in the room.
Right.
And see, okay, did the sensors see the same thing?
Right.
Did it see another entity? Did it see, did it trigger, did the temperature change? Did the, barometric pressure, did something happen during that button press?
All your bases are covered.
Yes.
Okay.
Pretty much.
Okay.
So anyways, that's how the board looks. That's what it does. That's how it works.
Now, have you ever thought about making it encased?
Oh, of course. But the problem is most of the sensors need to be out in the open. Because like if the temperature sensor was encased, the warmth of the board itself would start to make the temperature rise.
Okay.
The motion sensor couldn't see through it. The distance sensor couldn't see through it.
Okay.
It needs to be open for the sensors to be able to see it. Now, things like magnetic fields and the metal detector probably wouldn't care if it was in a plastic case because it can see the metal right through the case. Same with the radiation.
Right.
But things like the ions, the barometric pressures, the temperatures would not like being encased.
Okay.
So that's why we did that.
Okay.
All right. So now we're going to move over to our mock investigation so you can see what some of the data looks like and go from there. I guess before we do that, do we have any questions in the chat? Do we have people want me to go over some little part again?
I haven't seen anything of yet.
Okay, they're all scared probably because it's techie. Ghost people are techie, but sometimes when it gets a little too far, they're like, nope, I'm out.
All right, yeah.
All right, so I'm going to switch back just to empty screen here. Let's get out of this program.
I'll remove this.
There we go. I'm out of this. All right, you can go ahead and leave my screen shared. It's fine. They can watch. All right, so this is my lovely background with all my family coming in to visit. As you can see, All right, so this was a little investigation I did at a car dealership. They had some strange things happening. We didn't have it happen during the investigation, unfortunately. But they were complaining that they would lock up the place. They had set the alarm. They'd come in the morning and cupboard doors would be open, papers would be on the floor, and of course they called the exterminator because we got critters. No critters were found. No evidence of critters were found. So they're like, we need somebody to come have a look. So I came and had a look. And so I spent one night there, and we set up the board and we recorded a bunch of data. Also, like I said earlier, I intentionally triggered a couple of the sensors just so that we could have some data to work with tonight. I don't think we only had one small anomaly around 1 something in the morning. We were talking about some random stuff, and we had a fairly heavy, and then I was like, hey, can you touch the magnetic field sensor? And they touched the magnetic field sensor. It wasn't very strong. It was one time. I'm going to call it a coincidence, but anyways, we'll start from there. So anyways, like I said, it makes Excel files. So we're going to open up our friend Microsoft Excel. For all you techie nerd people, you'll be used to this thing. I'm going to set these things so we see the top row real quick here. So when I scroll, things will stay where they are. So anyways, I'm going to go across the data and just kind of show you what we got. This very first column here is the record number. It's literally just a sequential number, 1 through multiple thousands. A new number comes in every second. The next thing, of course, is the all-important timestamp. You can see it was 1:26 a.m. and then the seconds.
Just to interrupt you real
Yes.
quick, if people can't see this at home, the screen that he's dealing with right now, if you expand to a full screen, then you could see the numbers a lot easier.
Oh, thank you.
Just letting everybody know. Okay,
yep,
go ahead.
No problem. Yep. So, anyways, this is the timestamp, and this is from a blob of data that I grabbed from 1:26 in the morning. We were working on it.
Okay.
This next column is the touch sensor. I didn't play with the touch sensor, so it was all zeros all night. Nobody else did either.
Right.
Same with the flames. We didn't burn down. It was all zeros. Same with the metal. I didn't put a piece of metal near it, so it was all zeros all night. The motion, now you'll see we got some zeros, and then you got some ones, some zeros, some ones. That was me walking around in the room.
Okay.
It makes like 3-second thing. So for the 3 seconds, you got 3 ones.
Okay.
So that was motion. Infrared. This is the light. This is the level of infrared, and it's just a number between 0 and 1,000. So this was about 300 and something is the typical numbers, 350, 360.
Okay.
And the reason for this is we had a fluorescent light going right above where the board was sitting. We didn't do the investigation in the dark because I guess my opinion is that ghosts don't give a crap if it's day or night or dark or light or if the lights are on or off. I mean, they didn't when if they were still alive, people worked around in the day.
Right.
Kind of ghost hunting at night is like, okay, well, I guess you can do it, but you're scaring yourself, not the ghost. So, anyways, the amount of infrared light that was in the fluorescent light showed up as 300 and something. Next thing over again was the visible light, and of course it was much brighter because visible light for fluorescent light is pretty bright, so it was almost 700.
Mm-hmm.
And it didn't vary much because we didn't move anything and it just sat there.
Right.
UV is 0, and it's 0 all the way through because most fluorescent lights do not give off appreciable amounts of UV, or at least not UVA. So there's that. The distance. This one's an interesting one. It's about 150, and it stays that way because that's how high the ceiling is from the table that it was set on.
Okay.
So it sees the ceiling.
Okay.
And it stayed pretty close to 150 all night, which means nothing went over the top of the board and interrupted it. If you see a big dip, like if I run my hand and go across the board, you'll see that drop to whatever height my hand was above the board.
Oh, wow.
So that stayed about 150 centimeters, which is probably about 7 feet, 7 feet. So that's probably how high the ceiling was from or I don't know the exact distance, 150, whatever 150 centimeters is. If the height of a person.
Okay.
Up. Events. This is the events. Remember I told you if you press the button or if you flip the switch, it says I'm in a session. And they were all zeros because we didn't really do a session. This was more to collect data for you guys to show. Temperature, 16.2 degrees Celsius. And you can also see we started in the room, it was 16.1 degrees Celsius. Well, by the time we get down to the end, it was 24 degrees Celsius or more. You can see it's going up. That's from our warm bodies and the little space heater that we turned on in the corner of the room.
Okay.
So that's what happened. We didn't have, normally if you're going to see paranormal activity, you would probably see it do over a short period of time, and it would be a dip or a spike, not just this slow, gradual rise.
Right.
The room was, when we first came in there, it was a little bit chilly enough you'd want a fleece on. By the time we left, it was probably comfortable enough for t-shirt. So you could see the rise in temperature. In a little bit, we'll do a graph, and you can see some of these graphs. I'll move along a little quicker here so we can get get through all of our stuff. Next thing we pick up is humidity. Again, it's a number. Barometric pressure in millibars, just like you'd see on your weather report. Again, the dew point in degrees Celsius. Next column is EMF. Most of these stayed pretty low. Somewhere in the data we could pick through, I didn't remember exactly where, I took my cell phone and I put it right over the top of it,
Mm-hmm.
and it showed up no problem.
Okay.
The next one is ions. If it's a negative number, that was a negative ion. If it's a positive number, it was a positive ion. They fluctuated around between negative couple hundred and positive couple hundred. And the main reason is for that is most likely because my fleece that I was wearing had quite a bit of static in it. And those
Okay.
ions just emit it. And this room is small. It's probably 8 foot by 10 foot. It's a very small office.
Okay.
And so just me sitting in there, plus the natural environment does have ions all the time, and it's worse in the winter when it's dry than in the summer when it's humid.
Right.
So there's that. This next one is the plasma ball, which we didn't talk about that, but there is actually a plasma ball attached to the to the thing, and we'll see that here in a little bit. We'll do some live video and you can see what it looks like. So that's one of the things that I actually touched. So I had some sample data for you guys. This next one is radiation levels in microsieverts. For you techie guys, you'll recognize the sievert or the microsievert. That's a measure of how strong radiation is. The radiation in this location was very low, thankfully, because I do not want to glow in the dark.
Right.
Typically, it runs around 0.06, 0.07, maybe 0.1 if it's kind of a high location. Anything over about 0.3 or 4, I'm going to be like, something's wrong here. We need to figure out what's going on. There might be radon in the room. There might be natural uranium in the soil. You might have some radioactive dishware, something like that. I don't know. Anyways, these next 3 are the accelerometers, like I said, that sense movement of the board.
Okay.
And this one that says Excel Z, and it has numbers very close to 1. That's the force of gravity. You want gravity to stay around 1. If you took the board to the moon, it would be like 0.25.
Okay.
So basically, if it's not somewhere near there, you're either, not on Earth, or Earth's gravity has changed and we got problems. Okay, we don't want this.
No, we don't want that.
The next 3 are the gyroscopes, which tell you which way the board is pointing and how it's moving.
Okay.
So if you took it in an airplane, it would have all kinds of interesting data. And you could see ascent, descent, turning, moving, everything.
Okay.
The next 3 are the X, Y, and Z for the magnetic fields.
Okay.
And it's remember you guys in the Ghost Hunter group, we call that the tri-axis or 3-axis EMF meter. That's equivalent to that.
Okay.
And then this over here is equivalent to all 3 of these axes combined together into a single number, which just gives you an absolute magnitude of, okay, how strong were the magnetic fields here? The other 3 give you where the magnetic fields come from, and then this one tells you how strong.
Okay.
So that's all the things that it records every second. This particular one recorded 3,847 records. Okay.
Wow.
So if I go to my little friend over here, the Time Buddy, which is another little piece of software I wrote, and I slide it over here so you guys can see it, and I put in 3,847, and I can convert it. That was 1 hour and 4 minutes. So the board ran for 1 hour and 4 minutes during that time.
Oh, cool.
I use this little software also for converting. If I'm looking at a video, a lot of times it'll say it's like 10 minutes and 57 seconds in. Okay, so I could go 10, 57, and hit this. It tells me I need to go to record 657.
Oh, cow. That's pretty accurate.
That tells me which record I need to go to. So then what I do is I'd go in here, I'd open this up, I'd scroll down to, 657, And okay, this row has the data I need in it. So
Okay.
that makes it very convenient.
That's cool.
Yeah. So that's a little converter thing. So now, one of the things that I will sometimes do is I'm starting out, I haven't done any analysis, I just have the data. I have the data files.
Okay.
So I have this thing that I wrote that's called the anomaly finder. And it actually literally correlates the anomaly. So we're going to do a live anomaly find on this thing. So I'm going to double
Okay.
click this. This little tiny program comes up. It tells me what kind of threshold. So I'm going to do a threshold of 4. This means I'm going to be 4 standard deviations, which I'll do talk statistics here a little bit. 4 standard deviations I'm going to consider an anomaly. The
Okay.
other thing I need to do is tell this program what columns are binary data, which means they're just zeros and ones, because it needs to know, because zeros and ones are treated different than things that have actual numbers in them,
Okay.
because zeros or ones are just ons or off. We
Right.
also are going to ignore a few columns because those are things like the timestamp, the record number, some things like that. We don't care about those. And then we also tell it column 2 is our timestamp, because if we look here, column 2 is timestamp.
Okay.
So we tell it those things. We say analyze. Then we pick the file that we just downloaded from the board and we say open, and it analyzes it. And it makes a new file that is the results file. So I open this one in Excel and I'll expand out the fields. And so what this tells us is that our threshold was 4, we ignored some columns, and then it starts showing things. It shows the timestamp, and then also it shows what happened, what its value was, and if there's more than one thing happened in that same second, each row is a second, it shows it. So we had motion and we had some infrared light change, which is probably my fat head going over the infrared light sensor, blocking some of the light from the fluorescent bulb. So we got some infrared light, we got some motion, we got more motion. Most of this is me in this little tiny room. But we'll find some other ones. Here's a visible light. It dropped. If it's a negative number, it dropped by 9.1 standard deviations, which means my head probably blocked the light. We'll scroll down. There's tons of motion, just me moving around, some UV. Okay, here's one. Acceleration, negative 4.2. So basically, I probably bumped the desk that it was sitting on because it was kind of flimsy.
Right.
We also, here's where I touched the plasma ball. And
Okay.
we'll actually go and look at that here in a bit. But see, you can see it actually gave an alert for the plasma ball. And I physically put my finger on it. Matter of fact,
Okay.
actually, we'll look at that right this minute so you guys can see what that looks like. I made another. Actually, it's in my other one. I already had it open. I don't need to open twice. It's in my other spreadsheet. No, I didn't. I did close it. So I'll open it again. And I made a quick Excel graph. If I scroll up here to the top, this is a graph from the plasma globe, and you can see it's just going along. That's the natural, just whatever lives in the
Right.
noise. And then here's where I touched it. It makes this big blip where my finger physically touched, like ET style, touched the globe.
Okay.
And so that's what the data looks like if you graph it. Here was a magnetic field from that exact same time. You can see there's these couple spikes right here are in the same positions as these spikes.
Mm-hmm.
If you look, because this is time going across, this is 88 seconds going across. So we had a little bit of correlation. So basically what's happening is when my body physically touched that globe, the magnetic field created in my body by touching that globe showed up in the magnetic field sensor.
Oh, wow.
So it's very sensitive. So what we're going to kind of show here now, I'll probably go into a little bit of statistics, just so you can see what it looks like from the statistics point of view. So let's say we're going to analyze this plasma globe. I looked in the video and the plasma globe did something and I want to know what happened, okay? So I'm going to come to another little piece of software that I wrote. I write a lot of software. I'm a programmer by trade.
Evidently.
Yeah. So this program is a statistical software. You can use this for things outside of the paranormal field. You can use it for anything to do with data science, data things, where you want to find, medical study. Did this pill work better than the placebo? All those
Right.
kinds of things. So what we will do here is we'll go back into Excel and we'll grab some of its data. So I did 30-second catches. 30 seconds before I touched the globe, which is this area here, 30 seconds during while I did kind of touch it, and then 30 seconds afterwards. So we have two baselines and then an actual thing. Okay.
Mm-hmm.
So we're going to go in and we're going to grab the data. So I'm going to grab the first 30. It's counting down there. Okay, so there's the first 30 records. Okay. I'm going to copy it. No, I didn't copy. Copy. And I'm going to paste it in here. I'm also going to grab the next 30 and I'm going to paste it on the other side. So this is, the first was our control. So I'm going to paste it, copy, paste it over on the other side. And then I'm going to do the last 30 and I'm going to paste it on the first side because, again, these are baseline numbers. And this should be our last 30 right there. So I'm keeping those numbers, okay? So I'm going to paste this right down here so all of them are in there.
Okay.
So what I'm going to do then is I'm going to hit the calculate button and it's going to tell me if I had something statistically significant or not. Well, in this case, we should because I physically touched it. So I hit this button. You see we had 60 baseline readings. We had 30 during the little blip. It tells you some averages, some means, some deviations. And then this first group tells you that the average value really didn't change. But if we go down here to the standard deviation, which is a measure of how much did the data fluctuate, you'll see it says that it was false. We had a huge number here. We had a small number here, which means that the A data, which is this side, which is the baseline, is less than the B data. What that's really telling you is, in scientific terms, is you had an anomaly there and it was statistically significant.
Okay. Wow.
This H0 equals false means that the null hypothesis was false, which means you had an actual event. So this little event that you see up here, this blip, shows up and it's statistically significant blip, which you would want that because I physically touched it. Now, if a ghost or a person far away can do that same thing, then that's really cool. I would like to do that for me.
Okay, let's try that.
So far, they have not done this thing for me, which makes me sad. But I've only used it a couple times, so we're going with it.
Okay.
All right. So, anyways, that's a little bit about how I do my analysis. I can do the once over thing with this guy where I can look at the, did I had motions? Here I had some accelerations. I had a magnetic field anomaly probably when I walked by it with my cell phone on, things like that. So I do the once over first. If I see things that look exciting that I don't just recognize right away, then I dig into this side of it and I look for spikes, correlations, things like that.
Right. Okay.
So probably
So,
compared to the jump scares and all this stuff, the spooky and whatever, this is probably pretty boring. But
right.
if you want the real scientific, I can't say the word proof, but stronger evidence in the scientific way, this is how you get it.
Right. Right. And I think a lot of people don't realize that if you really want some of that, like you said, this type of verifiable evidence, then
Yes.
this is kind of, you kind of got to do your homework. You kind of got to do this, just, I mean, you can go into a haunted place and say, oh, yeah, I know it's haunted. I caught this EVP or caught this or caught that. But there's so much more to that than just catching an EVP, which is really cool because, I mean, different strokes for different folks. I mean,
Sure.
There's other people that were fascinated by this, and I'm fascinated by this, research that you've done with this, I never really looked at this side of the paranormal to
Sure.
that degree, but
Yep.
because knowing you for a while now and talking with you on how this all works, this is fascinating because the fact that it actually is very viable in a kind of like a proving or evidence type, not really proof, but I mean, it's like
Yeah.
proving there's something else
It
going
gives
on
you
beside.
unbiased
Yeah,
data because the
right,
computer doesn't feel things, it doesn't see things.
right, right,
It just records whatever the numbers the sensors tell it, and it
right,
says, "Okay, good to go," and you get the
right,
raw numbers.
right, right.
So the other thing I'll show kind of quickly here, I know we're getting towards the end of the time, um, is I've got a thing here. I think I can actually flip my camera. So if you want to minimize the screen share,
Let's see.
or just push this close, make the screen share the normal size, get rid of the screen share, or I'll just stop sharing. There we go. So then I'm going to flip my picture to my other camera so you can actually see the ball. You'll still hear me, but so here's the ball running, the board actually doing things. It's sitting in the living room here.
Mm-hmm.
Um, this is just so you guys can see what it looks like when it's running. You can see some little flashing lights. That little blink that you're seeing there is actually little bits of radioactive particles hitting the radiation detector.
Oh wow.
I'll walk over there. I'll put my Leatherman near the metal detector. Lights up. You see his metal. Um, I don't know. Most of the other sensors you probably can't. They don't really make lights or do anything. I
Right.
mean, for the most part, the board just sits there silently saying it's recording.
Mm-hmm.
Um, so, anyways, yeah. So that's how that basically works. And that's what it kind of looks like when it's running in a dark room.
Okay.
Not a lot of fun stuff to look at. Most of the time, I just put it down. We let it run for an hour or two. Then we come in. We do an EVP session for about 10 minutes. And then we go away for maybe another hour, come back in, do an EVP session for 10 minutes, and just repeat that throughout the night. Or we might
Right.
move it to a different room or a different part of the room or whatnot. And
Right.
so we'll do that. And then I, of course, keep track of when those sessions were. And so then during a session, we will be like, hey, touch this sensor. Can you touch right here?
Right.
Can you,
Right.
whatever, come into the room? Can you lower the temperature? Can you raise the temperature? And so I go back through the audio and listen for my verbal cues. Hey, can you do this? And then I check the next 30 seconds. Did they do it during that next 30 seconds? Matter of fact, sometimes I'll actually tell them, hey, we're going to give 30-second trials. I'm going to tell you to touch a sensor. You touch it, and I'll give you 30 seconds. And I'll actually time it on my watch. And then I'll give a minute or two for it to sit. And then I'll pick another sensor.
Right.
And then I can go back. And if during that 30 seconds I get statistically provable, not provable, statistically significant is the correct word, significant, then that's definitely one more thing in the heavy evidence. If they're touching the sensor you tell them to touch on cue, then that's pretty good stuff.
Right. Right.
And it has happened. It's not very frequent. I
Mm-hmm.
mean, this thing has been at dozens of locations, and only maybe 2 or 3 have done even a couple on or a few on command. But the fact that you can get it at all is definitely something.
Right.
So,
Right.
you know, what would be nice is if I could afford to have 3 or 4 of these and just fill a building with them
Yeah.
and just let
Right.
them go. And I've
Right.
even done things where put it in a place and just lock up and leave it go. Come check it in the morning.
Right. Right.
you know. So I
That's
guess at this
awesome.
point, do we have questions? Anything like that? We got about 5 minutes left.
No, I don't see anybody
All right,
asking
I'll
any
switch back to
questions.
myself so that you can see my wonderful mugshot and my face for radio.
All
There we go.
right. So all
So
that stuff is pretty fascinating in that sense, and I'm glad that talking with you and having you show that there's a different side to the paranormal field in this aspect, because there's a lot of people who really don't realize there is just more to just going out to either abandoned or haunted places, or whatnot, and trying to get
Yep.
evidence, and EVPs or whatnot. And not to say that any of the I guess material or equipment on the market today is all bad, because it's really not. I mean, some
No.
people have made some really good stuff and
Yeah.
this and that,
And
but I mean,
really, when it boils down to that, is a lot of the stuff is decently accurate and works.
hmm,
The hardest thing is you can only really hold or look at 1 meter at a time. So if
right,
you're
right,
wandering around with an EMF meter, you might be missing the temperature and three other things. The big
right,
that's the thing, and also to me, I found if you're carrying around things, you're spending so much time concentrating on, is this thing working? Does it got batteries? Is it reading things? Are we getting readings? And you're not focusing on what else is going on.
right, right.
So for me, I found it's nice. I can just bring this one board in and a couple cameras so I can videotape it
Hmm,
and plunk it down, and then, like I say, move from room to room. Give each room a couple hours over a course of a night.
right, right.
So
Well, I think that as far as doing this live like this and seeing how this thing works, probably going to have to do another show for that. I mean,
sure.
this has just been,
Yep.
you know, this has been a lot of information, a lot of good information that people really don't know about, and I hope that when people look back and to rewatch this video, we'll see that, hey, there's actually more to this than we thought, or
Yep.
how do I get more information about this, or you know,
Yeah. And
I
if you
guess
guys
there's,
have ideas for more sensors,
yeah,
post them up, because
right,
if it's not ridiculously priced or not available or NASA stuff that you can't ever get,
right, yeah,
I'll,
right,
I'll add more things. And again, like I say, someday I want to make maybe a second board, maybe with just a few less, just some of the main magnetic fields and ion fields and stuff. Maybe
right,
not
right,
quite as complex of a one. This
right,
was
right,
more of an experiment to figure out how much can I get at once,
yeah,
and just kind of a prototype. You can see it's pretty hand built looking. I mean, it's not
well, no, I mean,
usable, but
and
it's
it
not
actually
commercially
it
made.
looks great. I mean, it
Yeah.
looks, I really I like the way it looks. I think that in the future, I think that there'll be, like you said, building something a little bit smaller with the main, you
Yes.
know,
Mainstream look.
mainstream, or even the main pieces that go with it. I mean, that something
Yeah.
that eventually that is more of a handheld. This is more of a tabletop item.
Yes.
You know,
Yeah. And the big
but
thing too, also with handheld devices, is the people need to be away from it for it to work. So if you're
yeah,
carrying it around, that's another thing that you see ghost hunters carrying their meters all over the place. That's great, but your body is probably making 50% of the readings you're getting because you're
yeah,
holding the thing.
right, right,
Whereas I tend to put the board in the center of a room. If we do a session, we stand 6 to 10
right,
feet away. We social distance it,
right. Yeah,
and then
I know. There's quite a few people that try to put it away from themselves,
yeah,
and put it like in the center of a bed or a room or something
and
like
that's
that. But
fine. That helps a
you know what
whole
I
lot. I
mean?
mean, that's way
Right,
better than just
right,
holding it.
right,
Holding it and wandering around is just flashing lights and stuff for a
right.
fantasy.
Yeah, yeah. So there's different pieces of equipment that I've had over the few years that I just choose not to use anymore. I mean, it's kind of like you said before. Keeping things simpler. And
Yeah,
sometimes
truckloads
there's
of data. I mean, unless you got your own, you're a big enough group that you have your own roadies that carry in all your equipment.
yeah,
I walk in,
right,
I got one little Rubbermaid Tupperware container,
yeah,
that holds my board, a couple cameras, and a laptop, and I'm ready for the night.
right, right. Well, and that too. I mean, there's a lot of people that are in this field that do have a lot of equipment.
Yep.
Mainly because of the fact that they have a bigger
Well, and
team
they've been
or
doing it for years. They've
whatnot.
been collecting it.
Right, and
you
collecting.
know.
Yeah, yeah. I tried to get away from that. I didn't want to get into that habit of collecting.
the latest greatest gadget.
Yeah, because of the fact that not only is it expensive, it would make my wife unhappy.
Yeah, well,
So
there is.
yeah,
Yeah,
so
the budget committee usually denies your request.
yeah.
You filled it out in triplicate, but she's like, denied.
Right,
Not
right.
this month.
Yeah. So yeah, so it's but yeah, so I think we're actually out of time. But
All right.
I want
Well,
to
it's been
thank
fun.
Shane. Yeah, I want to thank you, Shane, for giving this demonstration and this
And we'll
information
do it
for
again.
this. And yeah, it was truly fascinating, and I've learned quite a bit from just knowing you, and especially tonight with this. So I hope that we can continue this a little bit more, so that we can
We will do it.
experience more and experiment with other stuff, and eventually we'll have you come here,
Oh yeah,
and
that'll
we'll
be
do an
fun.
investigation and whatnot. But no, so everyone who's watching, thank you for watching tonight, and hopefully you'll want to look back at this and kind of go through some of the information that Shane
Yeah, and
has
if you have
talked
questions,
about.
still
And
go ahead and post the questions.
yeah, feel free to shoot
Because I'll
either one of
scroll
us
through over the next
questions.
couple days, and
Yeah.
if I see
Um,
anything that's a quick answer, I'll throw them in there.
right, and this will be on our YouTube page probably tonight or tomorrow. So if you want to post any questions or what you have on there, or if you know um, know anybody, or if you are friends with me on Facebook, you can shoot me a question, and I'll try to shoot it to
Yep.
Shane and see if we can't get an answer for you.
All right.
So
Sounds good. Thanks, everybody.
thank you very much, everybody, and have a great night. And thanks, Shane.